Okay, so we are going to get going where we left off yesterday, so make sure you have highlighters if you need them. We're going to do something a little different today called Ed Puzzle, where you are following along with me and answering questions because I want you to still be engaged because this is a midterm and it's a big part of your grade. So make sure you are paying attention and following along. This will be taken for points. So when we look at this function, it says given the function and its graph, identify the following key characteristics. So the first thing it's asking for are the x-intercepts. Now the x-intercepts are where the graph, the function, crosses that x-axis. Now the x-axis is right here. That's the x-axis. So you want to make sure that you're looking at it and saying, where does that red function cross that line, that x-axis of, where does that function cross the line, that x-axis? We are looking now at here at -1, so -1 comma 0. And we're also looking right here at 3, so 3 comma 0. These are my x-intercepts. The next thing it asks is, where is the y-intercept? Now that's the opposite. Where does it cross the y-axis here in green? So it crosses that y-axis, that red function, at the point 6. This is going to be my y-intercept. And because we don't move left or right anything, we're going up, we're going left, right, 0, and up 6. And that's why we have a y-intercept there. Now, trying to remember back from chapter 4, your axis of symmetry is where that vertex is, that x value of the vertex. And that's going to be basically where you can fold that red function in half and it would be perfectly symmetrical. So that's going to be right here along that vertex, that x value of the vertex. So we are going to have the x equals 1, again, because that's the line right there in yellow for our axis of symmetry. You have to write x equals because that's a line. The axis of symmetry is a line, it's not a point. If you just put 1, I would have no idea what you're talking about. You can be talking about 1, where on 1? It's the whole entire line. So speaking of the axis of symmetry, because it goes with the vertex, our vertex is at 1 something because here is your vertex. That looks like that max value. So my vertex is right here. And that's going to be at 1 comma 8. Because I go right 1 and I go up 8. The next question, concave up or down. This one should be easy. If you look at the arrows here, looks like we are going down. We kind of talked about this a little bit earlier, but we do have a maximum because there are no points above the value of 8 that exist on this red function. That's why we have a max. Domain and range, you guys had practice with this on Monday, so this is when I put my infinity signs out. Domain is left to right, so that's this green part here, left to right. It's going to go forever to the left, and it's going to go forever to the right. So that's going to be my domain of all real numbers. But make sure you write it in interval notation because majority of time that's how it's going to be asked. Now the range is here in pink, up and down. So if you look here, again, you don't have to highlight all of this, but just for the visuals, I start at the bottom. There's function, there's function, there's function, all the way up until I hit this y value of the vertex. So I'm going from negative infinity, because that's where it's highlighted, all the way up into that 8 point. And it's going to be included. There's no hole, there's nothing. So 8 is going to be included into that range. That's why we have brackets. Now here's where you want to bust out those highlighters if you have them out. Because interval of increase and decrease is usually where people tend to struggle. And remember, that's always going to be your x values, not your y. So for the sake of just a visual tool here, I'm going to delete or white out all of these y values so that you don't get confused when you're looking at my graph when I'm doing it with you. You're not looking at y, you're only looking at x. You're asking yourself, where is the function decreasing and where is the function increasing. Kind of gave you that analogy earlier when we did chapter 4, that if I asked you, when am I going to be making money? From what point to what point? You'd be telling me like from year 1 to year 3. That's where it's at. That's when you're doing that. So when I do interval of increase and decrease, it's the same thing. So I always go left to right. So left to right in green. If you look here, ask yourself, am I increasing or decreasing as I'm going left to right? Well, I am going to be increasing. And you always start with negative infinity. I'm increasing from this negative infinity because it's going to keep going left forever. And I'm stopping at that x value of your vertex. So I'm stopping at 1. I'm not including it because 1 is neutral here. Now remember that now for decrease, you continue on. Because now look, in blue, I'm going to be decreasing. And I'm decreasing from the point that I left off at. I left off at 1. And I'm going to decrease all the way to positive infinity because I'm looking at my x values, not my y. If you were looking at y, I can see why you would think negative infinity. But we're not. We're looking at these x values right here. You're looking at the x values. Okay? All right, now let's flip to chapter 5. A rectangular prism has a volume of this. Determine the volume of the prism in standard form. This is when we were just multiplying. Lots of multiplying. I think you guys have gotten so much better at this. The first step you want to do is you want to just distribute this x into both of them. So I have 10x. Then I have x times negative 2x, which gives me a negative 2x squared. That's still going to remain in parentheses, but I have to bring down my 6 minus 2x because I've done nothing to it yet. Well, now we're going to keep going. Remember, first, outer, inner, last. That was that claw. So 10x times 6, 60x. 10x times negative 2 gets me negative 20x squared. Okay, so that was the first part. You want to take each part of that purple parentheses, the 10x and the negative 2x squared, and multiply it to both of the ones that are in black. So I'm going to then take this negative 2x and multiply it to 6, which gets me negative 12x squared. Then I'm going to take this negative 2x squared and multiply it by negative 2x, and I'm going to get positive 4x cubed. Now my final step here is just to combine like terms. The like terms in this situation are negative 2x squared, 20x squared, and negative 12x squared. So when I combine them, I get negative 30x squared. Then I bring everything else down, my 4x cubed, and my 60x. Now, on the final, or on this midterm, standard form, you go from the highest degree to the lowest. So that means that the x cubed must come before everything else. So I'm going to rewrite it off to the side here so that it's in standard form so we don't get confused. Now, again, that's only if it has the standard form. If it doesn't, then you could just leave it as is. So this is 4x cubed. I'm just rewriting it. Minus 30x squared plus 60x. And again, if you look here in green, it goes 3, 2, 1. And that's what standard form is. So that is my final answer. Number 2, looking at this function that's graphed to the right, we have to talk about each one of them. We just did this in chapter 5, and I think you guys are pretty good at this. The degree of the polynomial has everything to do with the highest power that you see. I see x to the 4th and x squared. Well, 4 is bigger, so my degree is going to be 4. Domain and range. This is when we always put these out so that we can use it as a guide. Domain of all functions besides radical functions are going to be negative infinity to positive. Again, because it goes forever left eventually and it goes forever right. Now we're looking at just the range. So remember, range is bottom to top. So the range, I'm starting here. This is where I'm starting. I'm starting at negative 2.25. And I'm including it. And look in blue, it's going to keep going and going and going, and eventually it's going to go up to positive infinity. Okay, so range is bottom to top, and it's your y values, your y. We have 4 x-intercepts here. Here's 1, here's 2, here's 3, and here's 4. So I'm going to write all of them out. Negative 2 comma 0, negative 1, 0, 1, 0, and 2, 0. Now the y-intercept is right here. It's where it crosses the y-axis. And now we're going to have that 0 comma 4. Now that relative max, see if you look here in pink, this looks like a maximum right here. And that max point is going to be at 4. It's going to be at 4 like we just said in the y-intercept when x is 0. Because that's right here. That's that max value. Now there are 2 mins. If you take a look here, they're relative mins. I'm going to have a min here, and I'm going to have a min here. And they're actually not relative mins. They're going to be absolute mins. So please fix that. That means that there's nothing less than what we have there. And I'm just going to put the points down. I have an absolute min at negative 1.581, comma, negative 2.25. That's right here. And I have another one right here at 1.581 and negative 2.25. Now, if this is moving too fast for you, you can always press pause as you're writing things down. Circle whether the graph is increasing or decreasing. So we're still looking at this graph. I'm going to erase everything. This is when you would want to use highlighters if you can. You always want to do left to right, and you're only looking at your x values. So always starting at negative infinity right here. If you look in black, I'm decreasing, 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 decreasing till I hit this x value. So I'm going to be decreasing from negative infinity to that negative 1.581. Where I stopped is where I now start my next interval. So I stopped at negative 1.581, and I'm going to now start my next interval there. Because here in purple, I'm going to start increasing now. If you see how that graph just took a turn, and I'm going to increase until I hit this next max point here. So I'm starting at negative 1.581, it should say, sorry, and I'm ending at 0 because that's the x value right here. That's the x value, 0, and I was increasing. Then in blue here, it's going to take a turn and start decreasing. And I'm going to decrease until I hit this x value, that turning point, at 1.581. So I'm going from 0, because that's where I left off at, and I'm ending at 1.581. Then this last little piece here, in green, I'm starting still at that 1.581, and I'm going to increase until I get to this positive infinity. So I'm going to be starting at 1.581, which is where we left off, and I'm always going to end at infinity, and I increased. Given the degree and leading coefficient, determine the end behavior. So this, again, sketch a graph because it's going to help you out. Or since you guys are really, really, really good at using your graphing calculator now, you can plug all of these into your graphing calculator and not even have to think. You can just tell me the end behavior. But for the sake of, learning about these functions, let's kind of talk about it. This, you always want to look and see what the leading coefficient is. Is it positive or negative? And what the degree is, even or odd. So this right here is telling me that I have positive, which means I'm going to be increasing at the end of my graph. And then this tells me I have even, which means I have the same end behavior. The arrows are going to look something like this. So if you were to sketch a graph, it's going to be something that looks like that. But really all you need to know is that these end arrows, because it's positive, which means I'm going up, and even, my arrows are going to look something like this, which means my end behavior will be shooting to infinity. And again, if you were to sketch that graph on the graphing calculator, you'd be able to see that. You would see that the arrows would end up here. And whenever you have an even function, they better be the same end behavior, because the arrows would be both going up here. Now let's look at this next one. I have a positive leading coefficient, which means I'm ending my graph here going up. But now I have an odd degree, which means I have opposite end behaviors. Now let's go to the graphing calculator in case you get stuck and you can't remember what it looks like. When you plug it into your graphing calculator in the y equals category, you're going to see what it actually looks like, and you don't even have to think about anything. So you want to go to that y equals, clear it out, and I'm going to type in what I had here. So I have 10x cubed, so 10x in red, and then cubed, you have to press the little caret symbol, and then 3. Press graph, and look, this is going to sketch it out for you. So when I say sketch a graph, just plug that in the calculator. Now look, as x goes to positive infinity here in yellow, that's x, it's going to positive. The function is going up, it's going up to positive infinity. And you guys were really good at this when we did it. Now as x is going to negative infinity in green, the function is going down. It's going down to negative infinity. And again, a lot of people like to write out this to help you out, because it does. As x is going to positive infinity in yellow, the function, however, in blue is going up. And then as x is going to negative infinity in green, the function in pink is going down to negative infinity. So here, let's go to the next one. Again, there's two ways you can do this. If you're good at your calculator, then just get out your calculator for these types of problems. But it's kind of cool how you know all this information. I have a negative leading coefficient, and I have an odd degree. So that right away tells me I'm going to have opposite end degrees. Remember, odd means opposite. So you can go to your graphing calculator if you can't remember which way the directions are going, which way. But remember, negative means that you're decreasing first. You're decreasing first. So it's going to look something like this. I'm decreasing first. But again, if you get stuck with that, then just refer to your graphing calculator, go get one, and type it in like I'm doing right now. Press graph. And look, it's going to look somewhat similar to mine. Okay, mine wasn't perfect, but it looked pretty close. So as x is going to negative infinity, here in yellow, the function is going down now. It's going down to negative infinity. And as the function is going to negative infinity, the graph, my function in orange is going up now to positive. And whenever you have an odd degree, you better have opposite end behaviors. Okay, that's what it means. Odd means opposite. Okay? Whereas when we did this first one, it was even and they were both the same. Now let's look at the next one. I have a negative leading coefficient with an even degree. So that is probably the best situation, because even means they're the same. And because it's negative, I should know it's going down no matter what. But if you ever get stuck, go back to your graph, clear it out, and type it in. Negative 5x squared. Press graph. And take a look. It looks somewhat like mine, but I can sketch it out for you so you can see. Okay, mine's not perfect, but all I'm really focused on is where the arrows are going. And they're both going down to negative infinity. Okay, I like even ones because they're a lot easier to work with. Use your calculator when it comes to test taking skills, whether midterm, final, JJC, in the future, entrance exam. If you have the ability to use a calculator and you know how to, it can be your best friend. So I'm glad that you guys are starting to get better at it. That graphing calculator, when you type it into the graph, it's going to give you so many answers without even having to think. Okay? So now let's go to this next one. Now I give you the graph, and I want you to tell me the opposite. So everything that we determined earlier, I'm giving you the graph now, and now you're telling me if it's even or odd, and if it's positive or negative. So here, take a look. The question is asking if it's even or odd. Even means that the arrows are going the same direction, and odd means it's going the opposite. If you look here, I have arrows going the opposite direction, so I should be answering odd. Now, when you're looking at leading coefficient, this is the harder one because they're opposites, so it's kind of hard to tell. But it's always where you are going to be looking at the end of your graph. You see here how at the very end, I'm going down, so it is negative. Or there's another way to look at it. When you are decreasing first in an odd function, it's going to be negative. Now let's look at this next one. This one's easy, and it kind of looks like the one on my graphing calculator. They're both going down, and they're going to negative infinity. But they're the same direction, and if it's the same direction, you're going to have an even function. So I have even, and I have negative. All right, next. You guys were really good at this, and I'm excited to do it again. We did a little bit yesterday. Describe all transformations from the parent graph. This negative 1/4 is telling me that I'm stretching or compressing. I am going to be compressing because my value in front is less than 1, and I'm compressing by 1/4. This next piece of information is going to tell me if I'm moving left or right. Now remember, and be careful, whenever it's in parentheses, it's the opposite of what you would think. So I am going to be moving left, and I'm going to be moving 2 units left. This last piece tells me if we are moving up or down. And this one's easy because we are just moving up, and we're moving up 6. Another one here, same kind of problem. I have this 6 out in front, but don't forget about this negative. The negative right next to this equal sign here is going to tell me that I'm reflecting. I'm reflecting over the x-axis. The only time it's going to be y is if it looked, I'm going to rewrite this, don't write this down. But if I rewrote this as f of negative x minus 3, that's going to tell me that we're going the y-axis. But most of the time, will be the x. Then here in green, I have a stretch or compress. And because it's greater than 1, you are going to get a stretch of 6. Okay, then I have my negative 3. And that's going to tell me that I am moving right 3. And then I'm going to have this negative 9. The negative 9 is going to tell me we're going down 9. Now remember when I told you in the past, you had that bright green sheet in your interactive notebook, but here's my original in yellow, x to the 4th. Do you see how on A and B, everything that's highlighted is different than x to the 4th? That 1/4 in A was not there before in blue. That orange piece, that positive 2, was not in that yellow function in the beginning. Either was the 6. That means that we're transforming it in some way. This one, you guys like this one too. Now this one was talking about your extrema. Now your extrema is those little humps and bumps here. This would be an extrema. This would be an extrema. It's how many times you're going to be changing your increase and your decreasing. So here you can see I'm increasing and then decreasing, and I'm increasing here. I changed directions twice, and that's called extrema. And so if you notice here, remember I told you that this technically would be an odd here, going off to the side. If it's odd, you're going to have even extrema. Look, 1 extrema, 2 extrema. So remember, we always went down 1. So I'm going to subtract 5 and 1, and I get 4. But then I kept going down by 2s. So I can have 4, I can have 2, and I can have 0. So you first start off down by 1, because you can never have odd extrema and then odd function. You can't. Okay, so you look at the example off to the right, I had odd function and even extrema. So here again, I'm going to subtract 1 first. So I have 6 minus 1, it gets me 5. So that's where I start. Then I go down by 2's. So then I have 3, 1. You can't have negative extrema, that doesn't exist. So we would stop at 1. Tomorrow we will do 6 and 7. So right now your task is to go on Power School Learning, which was haiku, and do that chapter 5 practice like you did the chapter 4 yesterday. And it's due by the end of the hour because this was a short lesson. Take your time, no phones, no Chromebooks, nothing until you are done. You can listen to music and go on your phone once you are completed with your haiku quiz. And I'll be making sure that you are being monitored. Be good and make sure that you are kind. Have a great day.